Welcome back. Now let's look at another topic within the symmetric cryptography called Shift Cipher. This is also called a scissor cipher. Okay. The scissor cipher was the very first individual to invent this specific technique of Shift cipher. So until now, we just looked at cipher that deal with the alphabets, and well, this is also all about shifting the alphabets of the English language. So for instance, if I say the shifting key as 3, well, this becomes, so let's say our A is shifted by 3, so it becomes D. Okay, B will be E. Similarly, the W would be Z, and then X will go back to A, so it will revolve, cycle back again from A. So this is the idea of Shift cipher. For encryption and decryption, we have a specific formula for this. Okay, so let's assume we have this X and Y. Okay, and then this specific key of 3, X being our input, Y being the output, and then the key. They are part of our ring. So in our ring, in our case, the ring now contains 26 letters. Okay, why? Because this is based on the English alphabet. So our ring is the list of integers from 0 to 25. Okay, given that this is contained, then for the encryption, we have the encryption of our X. Okay, we technically should call it Y as well, converting the X to Y. This is going to be equal to or equivalent to X plus K mod 26. Why? Well, this is our M here, so this 26 is our M, and we could call it mod M. Okay, this is encryption, and for decryption is the exact opposite. The sign gets minus here, so for the decryption, that would be this decryption, okay, from the Y. Now the word convert this to X, so this is going to be Y minus K mod M for 26. So this is the formula for encryption as well as decryption on this Shift cipher. Okay, let's do an example. So as an example, let's assume, okay, our key 17 and our plain text, let's say, is attack. Okay, now starting from 0, since the rings contains things from 0, 1 all the way to 25, total of 26 letters in there, which means maximum would be M minus 1, which is 25. So A would be the very first letter, it is 0, right? So the index of A is 0, index of D turns out is 19. Okay, 19, A is again 0, C is 2, 0, 1 and 2, right? And then we've got this 10 for the K. Okay, this is my X, so I can call this as X1, X2, X3, X4, X5, X6. Now let's perform encryption. So the formula for encryption is right here, right? Encryption of my X, it's going to be X plus K mod M. So the encryption of the first guy, let's say X1, okay, is going to be X1 plus the key, okay, mod M. So this is equivalent to this 0 right here. Encryption of the 0 is going to be 0 plus 17 mod M, it is 26. So it's 17 mod 26. This is going to give me the remainder of 17 itself. Okay, this is the first one complete. Now for the second one as well, do the exact same thing. For this 19, it would be 19 plus 17 mod 26. And it turns out, and this is how much is 36, so 36 mode 26. Well, this is going to give me the remainder of 10, and so on. So eventually it turns out, okay, our output, in our case, this is y1, this is y2. So we have this y1 is 17, y2 is 10, okay, y3 is also the exact same letter, which means it is also 10. y4 turns out is 17, okay, y5 is 19, and eventually this y6, okay, equivalent of 10. After conversion it becomes 1. Okay, now if I'm to write this in the letters form, on the 17th index we have the letter R. On the 10th, starting from 0, okay, we have the letter K. It's the same here as well. We got the K, and 17 we got the same R. Okay, on the 19th index we got this T, and eventually here on this first index start from 0, right? So we'll have P here. So this is after it's been converted, okay, and this is what we call as the ciphertext. Now on the receiving end, well, a receiver, once the receiver gets this specific message, has to convert it back to the original form. For that we use the other formula right here, y minus k mod m. This will convert it back to these numbers, and from here we could map it to these specific letters. Okay, just to demonstrate that, we have the formula of this decryption of y. Well, this would be y minus k mod 26. So my y1 in our case, okay, is 17, which means 17 minus k, okay, mod 26 would return me x1. Turns out x1 is 0, and let's see, 0 mod 26, well, it's 0, and we could basically use this formula to decode it back to the original, which means this will give us the answers of this 0, 19, 19, 0, 2, and 10. So this is the idea of Shift cipher. Now this, just like the other cipher we've studied, is vulnerable to attacks. See, this uses this English alphabet. Now English alphabet, we have total of 26 letters, so it's really easy to even guess them, right? The complexity is very low, number one. Number two, well, English alphabet are prone to letter frequency attack, right? Letter frequency analysis. So this really does fall victim to even some of the basic attacks that we have. This really isn't that secure. Now we have a little better version of this called the Affine Cipher. Okay, now this is a little more complex than the Shift cipher. It uses multiplication. So the formula of encryption on this Affine cipher, okay, is, well, given that, let's assume we have this x, y, a and b. Now it's going to take a and b, okay, two of them from the rings. Okay, let's say they are inside this ring of m, in our case is 26. So the encryption formula for this would be, okay, or in other words, encryption of x basically means we are outputting y. So y is going to be equal to my a, which is going to be part of the ring, times my x, okay, my input, okay, plus b mod 26. Okay, this is encryption where a and b and also x as well are part of this ring. So this is a little more complex as compared to the other one. And for decryption, okay, of y, in other words, we are going back to the x. So this is going to be equal to the inverse of a, now the inverse of a, okay, times y minus b mod 26, and this is the Affine cipher. Okay, I mean, we could use this first encryption formula to basically decode the decryption formula. So for example, here we've got this y is equal to this a times x plus b mod 26. That would be, let's say if I try to take the y the other side, a times x plus b, that would be equal to the y mod 26, and a times x is going to be equal to, let's put b to the other side, so y minus b, okay, mod 26. So x then would be equivalent to the y minus b mod 26 times my inverse of a. So instead of writing 1 over a, it's just write a inverse. Okay, this means if I try to rearrange them, it would be x is going to be equal to a inverse y minus b mod 26. So this is the exact same thing I have here, right, as the decryption formula.